Okey. Sonra şöyle bir atraksiyon var. Tamam. YouTube'unuz var mı? Bir kişi denese, baksa.
Var.
Geldi mi duyurusu? Yayına çıktı diye. Geldi mi?
Duyurusu geldi de yani.
Benim ismimden mi?
Evet.
Tamam.
Abone olun.
Abone olun. Bir dakika. Bir. Uygulamaları aç. Pandemi sonrası ilk defa bu şekilde bir uygulama yapacağım. Bakalım nasıl. Açalım. Evet. Okay. Okay, guys, welcome. How was the morning? You probably had mathematics class. How many of you are new students? A lot of you are new students. So welcome to Gebze Technical University and Computer Engineering Department. Rest of the semester, we will be together in many courses. This is your first course in our department. I also have some other duties, like head of Institute of Information Technology, director. Therefore, if you have any problems with the campus and other stuff, food, dormitories, please let me know after the class so that we can report it to the management. No, I'm fine. Next week, tomorrow there is an opening at 11 o'clock, I think. So it may delay our class, but try to be on time in class. If there will be a delay, we will do the class after the opening ceremony with the ministers, etc. Here again. Next week Tuesday, if there will be any, if there won't be any change, there are people coming from Huawei, Turkey, to talk about Huawei ICT Academy and competition for 2023-24. It's a worldwide competition where you can join. It doesn't matter whether you are first year student or not. So we will be welcoming you for the next week's event for Huawei ICT Academy. That also includes certain courses, which I will be talking about that, such as Introduction to Python, etc., or Artificial Intelligence, IoT courses. So next Tuesday probably will be passed with that activity. But the rest of the semester, we will be teaching you half C programming language and assembly language and the general principles of the computer engineering and science. So it's a kind of heavy class. Plus, you will have a laboratory, as you know. It's under a separate class name, and there will be sections, different sections, starting from the morning to the afternoon. The experiments are connected to this class. So whatever we do in the class are connected to the laboratories, but the actual laboratories is in your dormitory and in your house. So you are on your own laboratory. Today, I mean, whatever we do in the laboratory in the building is not sufficient. So you have to work yourself. Um, Normally, I will be available after the class Monday, Tuesday, Wednesday. Wednesday also I have a class, graduate class. But we have 4 teaching assistants for this class. So each of the 4 teaching assistants are available in the second floor, 2 of them in the third floor. So you can talk to them about your issues in the class and things that you don't understand. But the things you don't understand, first, you need to check the lecture notes and the book. This is an introduction course to computer engineering and science. It's an interesting course because it gives you motivation for the rest of the 4 years, or maybe we will principles of computing, assembly programming, C programming, some hardware interaction. We will be programming Arduinos. How many of you worked with Arduino kits in high school? I repeat, how many of you worked with Arduino kits in high school? Okay, 1, 2, 3, 4, 5. So it's not much. At the end of this semester, all hands will be raised. So I know it's a simple machine. Kids are using it, but they are using it differently. They don't do much coding. The problem is it is so simple. So it can teach you fundamentals and basics. And also you can purchase it. There are much better kits. We talked about, for example, Raspberry Pi. Anybody worked with Raspberry Pi before? 1, 2. Raspberry Pi is good, but it requires keyboard to purchase. It requires monitor to connect. So when you have a laptop and Raspberry, it doesn't work that way because you cannot connect it. But Arduino is different. It connects through USB, so it's a separate computer and your computer. So we are going to teach you how to communicate without its own program, how to write applications for that, how to write applications for the PC so that they communicate, and how to make projects with it. So together. Therefore, it gives you basics about communication, IoT, hardware principles, and it also makes you feel that what a computer is. There is a processor on it, certain power, draws current, etc. So it gives you some deeper understanding about what computer is. That's why we are giving very big importance to Arduino kits. And at the end of the semester, everybody is responsible in groups of 10 or 12 or 15, I don't know exact number, to make a project together. Those groups will be randomly assigned. Therefore, you're not going to select your partners in the project groups. And you will develop a project together and get a grade from that at the end after the presentation and report. there will be invited speakers throughout the class, because this course is an introduction course. So, such as next week, we will have invited lecturers to talk about their companies, how things are going in their company and in the sector. There'll be videos I am giving you, and you will be required to watch that video as a supplementary content. Sometimes I will be playing short videos in the in the class, and that will also be interesting, because I don't want to create a boring class. As you can imagine, the universities are changing, and after the pandemics, the expectation of student is different from the university. So if I only talk, and you listen, it is an imbalance that it becomes boring after a while. So I will try to make lectures as enjoyable as possible, so that you come. We use Microsoft Teams in university. Each of you have school email address, right? Using that school email address, you will log into. You will first download Microsoft Teams to your PC and to your mobile. Once you include that application to your mobile and PC, you will join to Teams. You will join to an organization. An organization, if you join with your email, school email, it will take you automatically to school portal. Okay. Then you will be able to join teams of different classes. We started that before pandemics, and I will be sharing the code of CSE 101 Fall 23 code on the department webpage, using that department webpage, or I can send you email from the student system. Then you can automatically add yourself to the class. From that pace, you will be able to read additional documents, access class notes, submit homeworks. Okay, homeworks will be submitted from there, and submit project files. So all the class interaction, or you can ask questions to the public, and others can reply, or because it's a team. So that each class, what we do is each class and each work group has different team, and communication is done through that team. It's also possible to give lectures using Teams, but since the pandemic is over, I don't want to use Teams. Now I am using YouTube to record my lectures, because somebody else may benefit also from the content. Any questions?
Teacher, sometimes I barely hear you. Sometimes.
I am planning to buy a microphone set, wireless microphone set for myself. I can do it, but today I'm somewhat sick. Maybe that's why. Normally people hear me if you don't talk, and you are not talking, so thank you for listening. We were in China 2 weeks ago with the vice rector. We made an agreement with 2 Chinese universities to exchange students and faculty. And if you want to go to China for studying, We have candidate universities, but you have to learn Chinese. Also, we make agreement with the Huawei ICT Academy. Now we are the support center of the Huawei ICT Academy in Turkey. So all other universities courses are connected through us. So we will develop policies and guidance to other universities. It's a bonus for us. That's why I'm sick. I got probably sick on the way. Yeah, that question has been answered. So, what is next? Classes will be in class. Exams are in class plus quiz. Homeworks are important. There will be like 5 homeworks. There will be project. And basically, if some important change doesn't happen, 30% midterm, 40% final, 20% homework, and 10% project is the ratio of the grade. We have a textbook, Glenn Brookshire, Computer Science and Overview. We don't use, there is also translation for Turkish universities, don't use it. Get the original one. There is also PDF versions available everywhere. So you can download and store the PDF version in your mobile phone. Okay, then you can read it on the way, anytime, anywhere. Our quizzes are random, so when we make quiz, I don't quiz everybody. I have a program. I run the program, and it selects 10 people every time. So only 10 people gets quiz exam. Others go at the end of the class. It will be easy quizzes, but you have to be ready. And only the last quiz you take is valid. So, for example, if you take the quiz in the second week, you have to be ready all the time because your name is not taken from the candidates in the random selection. You can come out again, and the last grade is always valid. Okay. And if there is a person remaining, there are people remaining at the end of the semester for this random selection lotteries, we will make the remaining one together at the end. The idea is not to give quiz burden to the class, but keep you prepared. Any questions? Yeah. Do you see my head in the video?
I don't know.
Can you check?
Yes,
I mean the angle of the laptop. For me, it's impossible to check myself.
No, it's not good.
Especially
It's,
Sure.
let's look at this.
There will be like 10 seconds delay.
Yes.
Now it's okay. Thank you. Yes.
as an exchange student in China, do I have to learn Chinese here, or when I go there, they will teach us?
They said they have Chinese school too for learning, but that will cost. So learning Chinese came out to be easier than I think. I didn't, but I know people who are learning it. So there's a possibility for you to learn Chinese here. I'm trying to convince Huawei people to arrange some Chinese teacher for the foreign language school so that we can offer Chinese as a second language because we are in ICT, information communication area and computer science. And I mean, as a producer, even as a producer, or you are working in a company and you are going to buy something from China and you are going to go for the visit, some Chinese is fine. I mean, not for technical writing maybe, but for business purposes, some Chinese could be nice. Therefore, it's interesting. Our secretary Sema Hanım is just started to learn Chinese using an online application. As a coincidence, so yes, we also already have an agreement with Taiwan Technical University or something for several years.
Is that Chinese?
Chinese. Taiwan is China, they say. So, as you know, we have a history of science class, and the second semester I am teaching culture of computation class. In both classes, in the first one, history of science, we will be covering the general science history and principles. In the second term, in the spring semester, I will be covering computing, details about the computing and historical things, plus which computing disciplines deal with which parts of the industry. So what can we do with computing in the second semester? In the first semester, it's more history, etc. Therefore, I don't push history of computing that much in this 101 class. I reserve my rights to the other classes like 151 and 152 historical parts. But from time to time, we talk about historical facts because you have to understand it to get a upper perspective view. You are not technician. You are not going to be technician or programmer. You will be engineer and scientist. So you have to understand everything from the top. So our journey starts with abacus from 1100 BC, and for thousands of years, mechanical things, rulers and measures were used, pen and paper. Then there was a slide rule invented 1617, and it has been in use until 1980s. Slide rule. Then mechanical calculator was invented in 1642, adding, subtracting, etc. And 1804, some programming concept is developed for what? For loom. Loom means dokuma tezgahı, fabric making. So when you are making fabric making, you have some interesting patterns, like a Turkish carpet, very interesting Iranian Turkish carpet, or a rose. So someone has to code the rose into the ties. So when you have a machine doing that, how are you going to code different color ropes up and down, make knots, etc.? How are you going to do it? So they someone in France invented a mechanical device with cards moving one by one at each one, and the shuttle was going left and right with the loom. At each time, it increases the step, and that way, by programming the cards with holes on it, big holes, not computer cards, and attaching them with different ropes, it was like a chain, increasing the program of the machine, and they were able to make nice patterns without human intervention. When you are making a carpet, for example, it's all human done. They have a master picture there, and they follow the picture at each line, right? By hand, by manually. So one guy made it is, his name was Jacquard. Jacquard invented the mechanical loom, automatic, this one. So it is early means of programming. Then, in terms of computing, Charles Babbage was around in 1830s. He invented some computation machines, but couldn't make it realized because it was mechanical. Boolean logic came out, and or etc. Then first electric tabulator 1880, first analog computer 1927, analog computer. Then digital computer is 1946, and during Second World War, with the invention of the transistor, from vacuum tubes to silicon and germanium. First germanium, now silicon. Computers and switching became smaller, and then after all years, we came to this day. It's a short history. There are more details on it, especially with analog computer. How many of you know who Richard Feynman is? 1, 2. Okay, now you know. 3. Now you know he is a Nobel Prize winner, physics scientist. He was what was the recent film about the atomic bomb? Oppenheimer. You all know Oppenheimer, right?
Yeah.
But this guy is more important in the project. He was also in the project, and I think, I haven't gone the film yet, but I think he was also in the cast as a Feynman. Anyway, he is very good in explaining things. In YouTube, you can search his videos. In one of the videos, he is explaining how computer is working from the scratch. This talk is given to the high school students, in a selected high school students, probably in Stanford University, in summertime. You will be watching this. It's a kind of long, so I'm not gonna play this. I'm not gonna play this, but you should watch it. It's not suggestion. Let's see if the sound is gonna come out. How am I going to start it? This is not added. Okay. The video link will be in Teams webpage, or you can just type Richard Feynman computer heuristics lecture. This form, that is one of the shots. Second question is, welcome again to the university, to our university. Some of you will be staying in dormitories, some of you are staying in the houses, and we have dormitories getting built very quickly, so it will be ready next year. Secondly, there will be, I think it is A101, by the train station. You may see there's a construction going on outside of the campus, next to the campus. That will be a cafe and A101 next to it for you. And inside, there is other construction going on in the entrance part, in the front side. That is health center. So if you have any problems with your health, if you want to see the doctor, that will be the place. Those two will be open very soon. So our terminology is there are engineering science, computer engineering, data science, systems engineer, a lot of different names for software engineering. A lot of different names are given for our jobs. But there is science and engineering, the main difference. Others are not that important. For example, universities give different names to attract more students, or they have too many faculty members, they have computer engineering, too many each other, then some of them get separated and they open up a software engineering and new students. That also happened. Let's see, network is okay. So science is something that is more interested in truth, understanding of the problems of the nature. If you want to understand a problem, if you want to solve a problem in general, it is called as science. If you do experiments and if you try to understand why something is happening. So if you are trying to answer why question, then it is science, or how. But based on the information you get from the science, if you are going to build something for human use, for benefit, for your boss, for your company, then it will be engineering. The difference between an engineering and science is, one, in engineering, yes, there is some, but curiosity is not required. It will be your job, you are paid, and the target is given. So at the end, nobody is expecting the best from your company. They are asking for a product, such as a Pima pen. So if you are buying a Pima pen from the Pima pen maker guy, are you expecting a new invention? No. What you expect is decent price, decent quality, and it should keep you away from the rain. a window, a glass window. So that is what engineering is like. There are constraints, there is a budget, price, there is a problem, and needs to be solved. That is engineering. When the science comes, new problems, curiosity, how, why, etc. It's more challenging, interesting, but it doesn't give you the answer all the time. It may fail, but it is for understanding the nature, basically. And without science, engineering is not possible. Okay? And without engineering, science stays as science. Doesn't turn into products. Any questions? First, the computer. The word computer is used for the people in the past. And actually, this is the Atlantic magazine, I think the most famous magazine in the world, right? In one article, 2013, in the past, computing power used to be measured in kilogirls. How many girls you have for computers, and government projects for computing or science projects, defense projects, there was a computer job usually occupied by women. The reason was it was little lower paid, and lower paid jobs were filled by women instead of men because it was a secondary job, etc., in the house. Therefore, up until 1960s, most computing work was on the hands of the woman, not men. And before having computers, the word computer means a job, a person, like temizlikçi, okay, like a cleaning person. So then it turned into a machine. There is a nice video by it's a short video. Let me try to play it, and let's check whether the projector is sending the sound correctly. If not, let's see. No, that is one slide after. This is also taken from the video, but I didn't put the video in. Here, the people you see are computers. They have a task, come by paper, they compute and give the result to the boss. So, today, when we say a computer, we understand that it's a machine. And basically, it has a memory. Computer should have a memory, should be able to do arithmetic and logic operations. It should have an input, and it should have an output. And some external storage sometimes. And in order to organize everything, there is a control unit. This is what we call computer today. and there's a video. I hope it's going to come out. If it doesn't come out, I will test the second one. Yeah. This is a simple computer architecture. Have you seen this before? Not yet. Okay, this is the first time. So, an early IBM film explains what a computer is. And it is very interesting and very nice. You will like it. But I will understand whether I can show, whether I can pass the sound to the projector. Yeah. Şuraya basınca çalışması lazım. This version doesn't do it. So let me turn it on from the other machine. Sıkılmıyorsunuz değil mi?
Hey MJ, I have another name for you. Craven. He's here on some kind of hunt.
Sesi, output'unu oraya vermem gerekiyor. Output kasıyor. Yes.
The hell's going on with me?
Oo. Bir dakika. Ne yaptı? Bir dakika. Screen'i birleştiremedi gene. Şöyle yapıyorum. Şunu birleştireyim. Ekranları ayırma meraklısı. Main display. Mirror for built-in. Ya mirror dedik. Mirror for kasıyor. YouTube nereye gitti? Hiçbir yerde yok. Hayda. Main display. Mirror for Casio PJ. Heh, oldu. Bulduk. Oh, thanks. Bu çalıyor.
You make a break after this.
Man, alone on Earth, has the capacity for abstract thought and the freedom to choose what to do or think. What he decides to do may be a subjective choice, a matter of personal preference. What he enjoys may be the result of his taste or education. But there are certain cases where there is, like it or not, no choice, where facts are facts and quite inescapable. Here, the computer is man's newest tool. In the Industrial Revolution, machines multiplied the power of his hands. Today, the computer can provide an enormous extension of his mental powers. But to use such a revolutionary tool properly, it must be understood, seen in perspective. Humans are artistic, fallible, inventive, original. Their capacities are tremendous. But in the realm of facts, where there is only one possible answer, there is no question of judgment or opinion, and where human qualities such as imagination and foresight are not required, computers are a priceless tool. Computers deal with numbers, and the complex calculations they carry out are the result of their ability to do many simple, ordinary sums with speed and accuracy. They can store numbers until required. And they can also do simple logical operations such as selection. For example, they can determine which is the larger of two numbers. All numbers larger than 13 can be separated from those that are smaller. It seems extraordinary that with such a limited number of abilities, computers can do so much. Yet, the letters of the alphabet can express the whole of human knowledge. A computer is a straightforward, everyday machine. A simple way of studying the principle of how it works is to reduce it to 5 basic functions. First, there is a means of input, which we will symbolize by a pair of spectacles. Next, there is a memory, or store, which we show as a bank of numbered slots. All instructions and data being worked on are stored here. Then there is the calculating function, symbolized by a desk adding machine. Fourth is the computer output. A typewriter is the symbol for this. Lastly, there is a control unit, represented here by a numbered dial. All 5 functions can, of course, be carried out by people, a human computer, so to speak. In studying the principles, the first point is that a computer is quite dead. It can do nothing without someone to give instructions. The instructions our computer can deal with are few and quite simple. The first one tells the computer to store a given number in a specific slot. But this is rather clumsy. Let us write it more briefly. The next instruction is to add 2 numbers in the store and then return the answer to the store. Again, it can be shortened. Similarly, computers can be instructed to subtract, multiply, and divide. A further essential instruction is to print out the result. And the final instruction is stop. A selection from these instructions can be used to solve any problem that this computer can tackle. Such a list of instructions is called a program. Consider how a program can be worked out to solve a simple problem. Here is a family of 4. The individual ages are known. The problem is to find out the average age.
Averages.
First, all the information, the data as it's called, is put into store. The first child's age in slot 1, and so on. The number of people in the family is stored in slot 5. Computers can only add 2 numbers at a time, so a running total of the ages must be made. First, the 2 children's ages in slots 1 and 2 are added together. Next, mother's age is added to the total. Then father's age. The next step is to divide the total ages, which is now in slot 1 of the store, by the number in the family, which is in slot 5. Instruction number 10 is necessary to obtain the required answer from the computer. And finally, stop. These 11 instructions make up a complete, if very simple, program, one that could be handled by our human computers. The computer
Any questions? Is it going fine? Are you understanding?
Yes.
Okay.
comes alive when the operator supplies it with
Now it is going to animate.
or program, as it's called. Each component
First.
has a separate function and only acts when told to by the controller. In this simplified computer, the reader is reading out the program instructions step by step and passing the data to the storer, who puts it in its appointed slots. The controller must know what part of the program is being worked on,
Counter.
so he clicks up his counter at every instruction.
We call it clock. Program counter.
Now all the data has been stored, and a running total of the ages is being made. Only 2 numbers are added at one time.
Only adds.
When all the ages have been added, the controller gives the next instruction: to divide the total by 4, the number in the family. The printer is then ordered to print the result. The final instruction is stop.
Stop.
For such a small problem, our human computer is more than adequate. A more realistic problem, a computer-sized one, would be to find out the average age of the whole human race. Assume that we have a list of every single individual age. At the end of the list is put the population total, 3 billion. The program could start. Store the first age in slot 1. Store the next age in 2. Add them together and store in slot 1. Store the next age in slot 2, and so on. But note how the program is repeating itself. There is a similar instruction for storing each age,
Store.
and another repetitive one for adding it to the total. The complete program will have more than 6 billion such instructions and system will be totally unmanageable. A drastic way of shortening it must be found. First, all the ages can be removed from the store, except the two that are actually being worked on. Then, instead of a separate repetitive instruction on how to deal with each age, all instructions after the third are replaced by a new general one, which returns the computer to instruction 2, ready to add in another age.
Change the counter.
The next instruction uses the ability of computers to select from alternative courses of action. A number over 999 can't be a human age, so this instruction is not acted upon as the ages are totaled. Putting it after instruction 2 means that only when the population total, which is larger than 999, turns up, will the computer move on to the next instruction. This is to divide the total ages in slot 1 by the population total in slot 2. The answer, the average age of the human race, is stored in slot 1. The next instruction is to print the answer. And finally, stop. By using a stored program, only 8 instructions enable a computer to work out the average age of 3 billion people.
Anladık mı?
Biraz.
Arka aynı şeyleri tekrar etmek yerine döngü yaptı. Ortalamayı giderken hesapladı. 999 girersen de bitti diye sonucu şey yaptı. Yani sequential işler çok fazla tekrar ediyorsa ben bunu bir döngü içine alırım mantığını ilk defa keşfetmiş oldum.
Our human computer could take this 8 instruction program and carry out the job. But as each age takes about 30 seconds to add up, even if everyone works at the maximum possible speed, it will not help very much. It is inconceivable that such techniques could cope with the huge volume of information that has to be processed today. A satellite is one of the most rapidly moving mechanical objects that man has produced. But even this takes about 90 minutes for the journey around the Earth. An electric pulse takes about a third of a second for the trip. Clearly, electric pulses are one solution to the problem of designing a really fast computer. Most electrical devices can be in 2 states. A bulb is on or off. A voltage is present or absent. A current is flowing or not. A magnetic field is in one direction or in the opposite. A switch is off or on. Man has 10 fingers and long ago found it convenient to tally things in groups of 10. This is the basis of the decimal system, which uses 10 digits from 0 through to 9. Any number written in the decimal system means so many ones, 5 of them, so many tens, so many hundreds, that is 10 by tens, so many thousands, that is 10 by 10 by tens.
Because of the fingers.
If an octopus were to study mathematics, he would naturally use the octal system, that is counting in 8s, using the numbers from 0 to 7. For the number humans call 85, he would write 1, 2, 5. One, 2, 5 in octal means 5 ones, 2 8s, 164, that is 8 by 8, total 85. Any calculation that can be done in decimal mathematics can be carried out equally well in octal. Electricity has only two fingers, so to speak, off and on. So for electronic computers, it is most convenient to use the binary system with only two digits, 0 and 1. What we call 13 is written 1101 in binary. 11, no twos, 14, that is 2 by 2, 18,
2 by 2
that
by
is
2.
2 by 2 by 2. Clearly, 13 can be represented by 4 bulbs, on, off, on. Similarly, current flowing or not flowing can be used. Or magnetism, one way or the opposite. Any of these electrical states can represent 13 or any other number. If the letters of the alphabet are given numbers to represent them, the numbers can, of course, be written in binary. The binary numbers, in turn, can be shown by light bulbs, on or off. Thus, Roma can be written out in 14 light bulbs. In this way, it is possible to put names or written instructions into a computer program. With all computers, the input must be in a form that can be handled rapidly and that the computer can recognize. A punched card is one widely used type of input, though there are others.
Until 1970s,
One
75.
or more holes in different positions on the card can represent any numeral, letter, or conventional sign. The computer program can be punched directly onto the cards by a machine which automatically converts ordinary text into the appropriate symbol. The cards can be fed into the computer extremely rapidly. The main memory or store of a computer consists of a matrix made up of 1 million or
Core.
more tiny ring magnets.
Core memory.
Each one can be magnetized by an electric current passing through it.
Each one is like
By altering the direction in which the current flows, the core can be magnetized in one direction, that is, store a 0, or in the opposite direction, and therefore store a 1. Such cores can store, or they can be read out, at almost the speed of light. The calculator, like all computer components, is a mass of electronic circuitry. It deals with electric pulses representing binary ones or zeros and can add, subtract, divide, multiply, or make selections from any numbers. The function of the control unit is like that of the conductor of an orchestra. He brings each section or instrument in at the appropriate time, but follows a score, in computer terms, a program, written in an appropriate code by another person. The computer output can be by means of a printer, which converts all the binary information into words or figures. But computers do many important jobs that need little actual output. They control industrial processes, for example, and keep records. In such cases, they only report exceptional or unusual facts. When the output is large, it can be on magnetic tape, or magnetic discs are very convenient, or the output can be punched cards. In some circumstances, it is more useful for the computer to actually show the results as a television-type display.
ilk zamanları.
Or you can telephone the computer and listen to the appropriate recorded answer. The results produced are reliable because there are inbuilt circuits which cross-check every stage of the calculation. Speed, then, and the fact that it is automatic and reliable are the computer's two strong points. A major calculation might take an unaided man a year.
Slide rule.
The computer would do it in less than a second. so computers can solve, or at least help with, problems impossible for men because of the time involved. Nor indeed should men have to do such tedious work. But computers have no originality, no initiative. If a computer lands an aircraft, it is only because it has been precisely programmed to do so. A man's judgment will tell him immediately which of 2 or 3 alternatives will be the shortest route across a city. A computer would have to be programmed with the length of every road and its terminal points.
Navigasyon ilk şey.
It would then add up the thousands of alternative routes and select the shortest in a fraction of a second. But unless it was specifically programmed, it could never know that the riverside is beautiful, and so this can make a journey seem shorter. These children are going to grow up into a world in which the most important technological factor is the development and spread of computers. Yet already they are mastering all that a computer can ever know.
Bunlar sizin anneniz
How
babanız.
to read, how to do sums, how to group things together, how to weigh up numbers and decide which is the larger, how to select the correct shapes to fill empty slots, and finally, how to write. These are the only things computers can do. Anything more is done by the men and the women who write the programs. Our material world is entering a period of rapid change in which computers will increasingly affect all our lives. Already the people of one city have been polled as to their preferred living pattern for the end of the century. A computer produced this plan for a city of the future by processing the individual desires of 500,000 people for different types of homes, methods of transport, patterns of leisure and of work, together with the expected population growth and the resources available. But the computer could only offer a series of mathematical concepts. It is to the degree that we understand this powerful tool and how best to use it that we can gain the maximum possible benefit. For only men and women can ensure that this city of the future will be a place of beauty and tranquility.
It's finished. Okay, did you like it? I think it's one of the best films that explains the numbering system, why we are using binary numbers in computers, and how the CPU is organized. That was the CPU, the table thing. There is no better explanation than this. In addition, the Richard Feynman's video is also one step beyond of this. So you will understand that much better after watching this one. So yeah, let's give a break, short break, and come back. Okay. Hala yayın var mı?
Hocam merhaba. Bir şey soracaktım da var.
Bir dakika şu slide'ı geri koyayım.
Bir şey soracaktım. Yarın da dersimiz var ya hocam. Şimdi ben CS 233 tabi dersi aynı anda yapıyorum. Laboratuvar dersi var hocam. Şimdi biliyorsunuz laboratuvar derslerinde hani 4 saat gösteriyor programda ama biz hani 2 tanesine giriyoruz. Çakışma durumu söz konusu. Yapabileceğimiz bir şey var mı hocam? Danışman hocaya sordum.
Buna girmeyeceksin. Burada buna girmediğin için bazı dezavantajların olacak. O dezavantajlara katlanacaksın. Videolar var. Oradan takip edeceksin. Yapacak bir şey yok.
Yani
Quizlerin bazılarını kaçırma ihtimali olabilir ama çok önemli değil yani.
Yani salı günleri video mu izleyeyim diyorsunuz?
Gelebiliyorsan gel. Gelemiyorsan da gelme. Ne yap? Nasıl? Ben yaratamam ki bir şey.
Yani biz danışmak istedim yine.
Ne
de
danışacağım mesela? Ne bekliyorsun ben? Gelmesen olur mu ben anlayayım?
Hayır hocam. Laboratuvardan dediğim gibi hani 4 ders oluyor ya hani 2 tanesine giriyoruz. Yani çakışma durumu olabilir, olmayabilir. Yani kesin.
Olursa gelemeyeceksin.
Hı hı.
Olmasa da geleceksin.
Daha çok tavsiye amaçlı sormuştum. Teşekkür ederim.
Yani idare edersin yani. O
Hı hı.
dünyanın sonu değil. Yani salı günleri lafım var diye seni ben ya gelmedi diye devamsızlıktan bırakmam.
Hı hı. Peki hocam.
Ama dezavantajım olur.
Evet, biraz gelemeyeceğim. Evet. Peki teşekkür ederim hocam.
Sıkılmıyorsunuz değil mi? Genelde bu kadar video izletmem. 151'de bazen izleyeceğiz de. Şimdi o kadar gerekmez. Ama bu çok güzel. Yani bunu izlemezsen olmaz.
Bilgisayar nasıl? Doğru olan bir şey. Şey diyorsunuz mu? Bir Feynman tekniği diye öğrenme tekniği diye bir şey var işte. Böyle 5 yaşında bir çocuğa anlatabiliyorsun.
Okey.
Onun
Başkası
işte
kaldı
alakalı
mı acaba?
böyle
Var hocam,
bir
evet.
şey var, böyle tekniği var öğrenmek. Evet. Ben de şimdi kaçta 6. sınıfta kullanacağım. Ya ortaokul ama kısmı
Havasız kalırsanız arkaları açabilirsiniz orada.
Aynı kafam benim. Kendi özel olarak düşünmüyorum orada.
Okay, so you have you had some idea about how computer is organized, and that is one of the best videos that one can find to explain what a computer is and what a CPU is made of. That 5 guys around the table. So one of the guys who was making the computation with the adder or subtractor or multiplier. The woman on the right bottom was arithmetic logic unit. It was capable of, she was capable of making arithmetic addition, subtraction, division, etc., and giving the result to the output. Basically, all computers, all CPUs have arithmetic logic unit inside, and it's a simple device made up of transistors. At this point, I have to explain what a transistor is, but electronic circuit, let's say, at the beginning. You give 5 from one side, 6 from the other side, and arithmetic logic unit outputs, if it is temporarily configured to addition, then it outputs 11. It's like a calculator, but it's instantaneous. How? There is a circuit inside. This is the real circuit made up of gates. That is what arithmetic logic, simple 4-bit arithmetic logic unit, no, 4. Yeah. So it's made up of gates. If you set it to subtract, then 5 minus 6, and 5 and 6 in binary. Divide 5 divided by 6. Okay, output shows the result. That is what arithmetic logic unit, and this is the symbol of showing arithmetic logic unit in digital electronics, in computer design. Now, we haven't come to the point of binary numbers, electronics, etc. But briefly, there is an arithmetic logic unit. Arithmetic and logic. Not at the same time, but depending on how you control it. Like a bulldozer machines, where you have many levers to go forward, backward, up, down, etc. Right? So if you set it to add, 2 numbers are added. Subtract, and or divide, multiply. So by given the controls like this, S1, S2, S3, S0, S1, S2, or more, the operation on these 2 inputs change. Behavior of the electronic circuit changes. It can be mechanical. You can actually make it mechanical too, but it will work slower. The simple arithmetic logic unit can add, subtract by one, decrement, meaning subtract minus 1. Efendim. Dersteyim şu anda. Ben size geri dönsem olur mu? 1 saat sonra. Tamam. Bay bay. Increment. And or not. If it is 1, the result will be 0. If the input is 1 0 1 0, the not version of is 0 1 0 1. Okay, invert everything. Or XOR. Efendim. Dersteyim. Daha sonra arayabilir misiniz? Bye bye. Burslar koordinatörlüğünden Gebze Teknik Üniversitesi. So then the concept of logic gate comes up. You may have heard about logic gate. Did you? How many of you heard about logic gates? Okay, not much. So I have to slow down then. Okay, let me find the white space. You have a battery, 1.5 volts. .5 volts can mean 1.5. As a number. Or it could be 10. I mean, 1.5 may mean 10. 10 lira. Another 1.5 another 1.5 as a number. These are volts. How do you add these two numbers? Think about it. Make a circuit. The circuit will be like this. What do you get? Ama konuşun artık. Bunu da yapamayız. 3 volts. So what have we done? We add. We make addition. If I am going to subtract another 1.5 from the 2, how am I going to do it? I put one here in the opposite direction, right? Then it will be subtraction, right? $12 volts here, right? What is the voltage at this point? If the voltage here is 12 volts. 12 volts, right? If I'm going to divide this 12 volts by 2, what am I going to do? Let's put 1K resistor here, 1K resistor, 1 kilo ohms. I don't want too many current going through because I'm not interested. Then if these resistors are equal, R, then what I read from here is how much? 6 volts, right? If it is 2K, how much? 4, right? Do you understand? So I can add, subtract, divide, multiply. How am I going to multiply? Sıkıştınız köşeye. Then we have, that has been a challenge of computation machines for a long time. Then mechanical ones were available. For example, there are gears. Okay, and there is a big gear. Okay, let's say there is a lever here. Okay, another lever here. This has how many teeth? Let's say this has 10 teeth, right? And this has 60. So if I rotate the small one by 10, this rotates 1/6 of it. Or if I rotate this big one by 1, the small one rotates 6 times. So it's kind of multiplication. That's how Charles Babbage was moving on with mechanical computers. And also, if I rotate this 20 degrees, how much this arm rotates? 20 times 60. No, 6. Right? 120 degrees. So it is multiplying the magnitude by using some ratio. But with electric, how? Any suggestions? Can you do it with water? Can you control big amount of water using small amount of water? Assume that you can control the water flow in a big water line by using the water power coming in another line. So with the small open on and off valve with your hand, you can turn on and off big amount of water. How? Because you design a valve system running with the water pressure coming from the small pipe. It rotates this way or that way with the power of the small water. Then it can let the big water go or not go. Then it makes amplification. You can make it like that. But making a computer using water power is difficult. It is tried in the medieval time. There are some machines. So the answer is multiplying electrons in order to make electric bigger, voltage bigger. You need to have multiplication capability. The biggest, let me become clearer. Alexander Fleming invented the vacuum tube. It multiplies electrons. You heat, this is the wire, like the wire in the lamp. You give 12 volts here, and the wire here becomes hot. Ordinary job, right? It's a simple lamp. But put a plate here
connect this and give 30,000 volts between this plate and this wire. Also keep giving 12 volts. So lamp is functioning fine. What happens? There will be some electrons because of the voltage drop. There will be some electrons moving, jumping from the air, moving to this part. So that's how we developed TVs, vacuum tubes, and all the oscilloscopes, many of the visualization, early CRT, TVs, CRTs, everything, and also the vacuum tubes. It flows, there is a current. So a lot of flow, a lot of electrons. But still, it's not controlled. How am I going to manipulate it? By playing with this 30,000 volts? Maybe, yeah, we can do it. But they put another thing here. They give voltage with respect to yeah, here, something in the middle. When they give some voltage, because this is too far away, they keep it in very threshold. Normally they can't jump, electrons can't jump. But if you give some excitation from the lens, from little bit from the middle, they become more energetic and starts flying. So if you give more voltage from here, these electrons that are here starts flowing. If you drop this voltage, they stop because it is too far away. You adjust your lamp that way. That is how electron tube is invented about 100 years ago. And the thing, like lambalı radio, lambalı amfi. Okay, those lambalı things, lambalı bilgisayar, ENIAC, etc. All the old first time computers with bulbs. Those are the bulbs. Work in this principle. The main principle is controlling big amount of electron flow using small amount of electric proportionally. Okay, when you do it proportionally, it becomes linear, analog. If you control it on off, then it becomes digital or discrete. These bulbs are still used in special type of amplifiers by high fidelity audio enthusiasts. Hi-fi systems, some of them use bulbs for the amplification because their behavior, not the people, the bulb's behavior is more linear than transistors. Later, this thing is replaced with the transistor technology, where you have this symbol, semiconductor technology. This is the base, this is the emitter, and this is the collector. Okay, so the current flowing from this, from top to bottom, can be controlled by the current coming from the base. Therefore, by controlling the base, I can control this big event, similar to here. But the behavior is little bit non-linear. So audio professionals don't like the sound of transistor amplifiers. They want to use expensive, old-fashioned bulb type amplifiers with very expensive loudspeaker sets in a special rooms
So because they have so much money. Okay, there are some people in Turkey too. When you have so much money, you tend to look for other things to put your money in. High fidelity audio is one of the hobbies that those people are. So I was trying to multiply, right? I was trying to multiply electrically using electric, and transistor is today's multiplication mechanism. In the previous years, bulbs, electronic bulbs, vacuum tubes were used to amplify signals. Today we don't, except audio enthusiasts. And also, I think they are being replaced, but since these bulbs are possible to manufacture in very high power, radio broadcast station amplifiers were using vacuum tubes instead of transistors. But today, transistors are also powerful enough so that they can be used in radio broadcast stations, radio and TV broadcast stations. So transistor is the key. When you make a transistor, let me write here. When you make a transistor, for example, you have 12 volts here, ten kilo ohms, 1 kilo ohms. No, again, yeah, 1 kilo ohms. When you give a signal like this is ground, when you give 1 volt from here, 1 volt, you will observe this is the output. You will observe like .5. This is 0.5. You will observe 7 volts here. When you give 2 volts, you will have like 4 volts here. So it works in the opposite direction. If you give something like this, small variations, here you will have bigger variations in reverse direction because you are taking it from the collector. That's the detail in electronics classes. If you take this way, it's on this side. For the amplification, you use the other part. But transistor amplifies, multiplies the value here with some coefficient and gives output. We can use it for generating analog multiplication. But for digital, no. It is only digital that we use in computers. The things I was talking about, these are analog. Multiplying
analog, multiplying analog. But with this, turning on and off, then we can switch to digital. With the transistor and with also the bulb, with the transistor, if you give, for example, 5 volts from the base, transistor becomes connected. If you give 0.5 volts, it becomes disconnected. Open circuit, short circuit, open circuit, short circuit. In between, I am not interested. It works, but I am not interested. That is what we call switching circuits. Switching circuits. And these transistors, that type of transistors are called as switching transistors, not amplifier transistors. Their characteristics in linear amplification is not important because nobody is interested in amplifying audio signals or video signals. They are interested in turning off and on. Okay. So using transistors, we can make logic gates and, or, XOR, NAND, NOR, XNOR. And in high school logic class, you have seen this. I know because my son is taking the same class. Do you remember logic operations? Yes. Do you remember De Morgan law? Name is interesting. You all remember it, but if I ask, maybe you can't write. Anyway, these gates must be implemented by circuits, by transistors. Each gate can be implemented by 5 or 6, correctly, nicely, 5 or 6 transistors. Okay. This is the transistor. Power transistor. This is also power transistor. This is smaller power transistor, signal transistor, surface mount transistor, germanium transistor with metal cap. Each transistor has 3 legs: emitter, base, collector. There is a different type of transistor called FET. That is field effect transistors. In the field effect transistors, like CMOS, you may have heard, instead of base, emitter, collector, you have gate, source, drain. Functioning is the same. CMOS works through the voltages. Transistor works through the currents. They are semiconductors, silicon. There are PNP ones, NPN ones. Interesting facts about it. If you are interested, just type on the Google, what is the difference between PNP and NPN? What did I say here? The wire and the 30,000 volt anode. This is called as cathode. This is called as anode. Right side is the anode. Okay. Electrons jump from the cathode because there is a too much voltage. Yandım Allah şeklinde. And start flying to anode. And the cathode is hot. That making it hot makes it easier to jump out from the wire. But they make it a little bit more distant so that it doesn't happen. By placing something in the middle, they can control it. Yes or no. They can start and stop the flow of electrons. So we need a control mechanism. Can I pass or not? That kind of control. That's why we say
semiconductor. It is not conductor, but it is sometimes conductor. How? When I want. Therefore, silicon and germanium are two main elements where electron numbers in the orbits are, I think, like 4, not 8, but 4. So it is not, it doesn't have excess, it doesn't have excess electron or missing electron, something in between. If you put little bit more electron to the orbits, it becomes conductor. If you take that electron, if you don't do it, it stays as insulator. So by injecting additional electrons, you can make it as a conductor. There are N-types, P-types silicons. Some silicons, you put some aluminum inside, so it turns, some electrons are more, so we call it as N-type. You put arsenide, I think, then it becomes P-type. I don't know the details. It's chemical process, so little shortage of electrons or excess of electrons from the neutral side. So N, P, N. Normally, from plus to minus, it becomes less electron, more electron, less electron, NPN. So it becomes insulator. But if you provide some electrons to P part, like a vacuum tube, then this turns temporarily, this turns to N, then current flows accordingly, less or more, depending on how much you provide, so that you can use it as an amplifier, controlled amplifier. For PMP, instead of giving electron to middle part, you take some, then current again flows. PMP is shown this way, and PN is shown the other way. There are rules. Rules are not that important for you. You are not an electronics guy, but you might be making double major with the electronics or taking classes. This is interestingly important. So this allows us to control on-off issues and amplification issues using semiconductors. In future, humanity is planning to use one, quantum phenomena to control states. Second, using light instead of electrons. When we are dealing with the light, instead of electrons, we will be using photons, which will consume smaller energy, will be more dense. But photon switching is in experimental stage now, so there will be time for us to make integrated circuits using photons rather than electrons. Today, we have to rely on electrons only. Okay. Using Süre bitti ama 5 dakika daha yapayım. Using transistors, we can make chips. This is the chip that was famous. We used to work on this when I was like you. This is N-type, P-type, and there is an other substrate on that, and aluminum for the conduction, for the wires. Wires are aluminum, and there are P. What they do is they take silicon, they put it in a chamber and put a mask on it. Chamber has for example, certain gas molecules condense, they wait in an oven, gas molecules condense and create certain parts as P. Then they change the mask, different locations, put different gas. Those different gas molecules are also implanted in the substrate by diffusion. They put aluminum, another using vapor technique. Connections are made. Another one. So multiple layers like this are formed. Okay? That is how I see manufacturing is done. 1974, Motorola company in 1 megahertz frequency, 8-bit data bit and 16-bit address. It had 4,000 transistors. That is the important part. 4,000 transistors. Each transistor looks like that in a small area. How big was it? I think it was like 6 millimeters square, 2 millimeters by 2 millimeters, or 3 millimeters by 3 millimeters, or something like that. Not big. So the chip is big, but actual chip is in the middle. The rest is the wires. This is the actual image showing 4,000 transistors. That is the first microprocessor. That is not the first, but first commercially very popular microprocessor at that time. There are successors, 68,000 and 6502. Some of you may heard Commodore 64 computers of your parents. Commodore 64 was using MOS 6502 processor inside. Then these gates have symbols. I will be talking today. I think you are tired, or I am also tired. Today we will be continuing from this part. Tomorrow. Tomorrow there will be an opening. Minister is going to come. We don't know what will happen. So be around, but also watch the ceremony in the campus cultural center. I hope you will see. If I can't make this class at 1:30, I will eat 151 instead. So we will skip 151 for this class. See you tomorrow.
Hocam,
Yeah.
yarın sizinle aynı anda iki dersiniz gözüküyor.
Aynı anda değil onlar.
Değil mi?
Arka arka. Aynı anda 2 ders nasıl oluyor?
Evet, programda hepimiz de aynı anda gözüküyor.
Göstersene. Yarın 1:30'da dersimiz.
Saat olarak aynı saat diliminde sadece
Neresi bu?
salı günü.
OBS'ye bakma. Arkadaşlar, ders programı için bölüm sayfasındaki programa bakın. OBS'ye bakmayın. Her zaman. Bölüm sayfasındaki duyuruya bakın. Çünkü OBS bizden 3 ay evvel istiyor. O kafasına göre yazıyor.
Bir de bizim çoğumuzun ders kaydı onaylanmadı da.
Yayını kapatayım. Ne yapıyoruz? Bir dakika. Stream. Evet.